Welcome again, students. In previous video we studied about electric field and that was introduction of electric field. So now in this session we will try to find out electric field produced by a point charge system. So first we will consider a source charge which is point charge Q, and then we will try to find out electric field produced by it. So here we will take a coordinate system, suppose XYZ coordinate system. A charge capital Q is placed at center of it. Positive charge capital Q is placed at the center of it and it is producing electric field around this charge. We want to find out electric field at certain distance R. For example, we write point P here. We want to find out electric field at point P. Now, how to find out electric fields? So, according to definition, electric field is electric force acting per unit charge. So, first we have to place point charge there. So, here we will try to place one point like small positive charge plus Q. And now we will try to find out force acting on it. Here, if you see the direction of force, then positive charge will repel positive charge, so force acting will be in this direction. And what will be that force? This distance we have considered R. So here force acting on it, F is equal to K capital Q small q upon square of this distance according to Coulomb's law. Now, direction is represented by unit vector, which is unit vector in this direction, outward direction. So, if we take this q here, so F divided by q is equal to K capital Q upon R square into caret R. So, by definition, F upon Q is electric field. So, this is E, that is equal to K capital Q upon R square into caret R. So, this is simple formula of electric field produced by a point charge. So, see here, electric field first depends on medium in which charge is placed. If we change the medium, then definitely electric field will change. Second one, electric field depends on the magnitude of source charge. Higher the source charge, higher will be the field produced by it. And third important factor is electric field depends on distance at which we have to find out electric field. So in this particular case, for point charge, magnitude of electric field is inversely proportional to square of distance of that point. That means if we increase the distance and make it twice the initial value, then electric field will be reduced by 4 times. So as we move ahead, electric field decreases very fast. So if we draw graph of electric field variation with respect to R, then it should be like this. This is electric field and R is distance from that particular point charge. So here variation is 1 upon R square. So it will decrease like this. So this is graph of electric field with respect to distance. So here mathematically electric field will become 0 at infinite distance. If we place infinite over here, then E will become 0. So actually by theoretically this charge can create electric field up to infinite distance. But practically this is not possible. After certain distance, electric field will be so small that it won't create any effect on another charge. So this was about electric field produced by one point like charge. Similarly, we can also find out electric field due to system of charge particles. That means multiple charge particles. Now, multiple charge particles can be arranged in two ways. One, they are in continuous form. Like suppose this is a body and on which we are charging. So charges will be continuously distributed on this body. Another option is charges are separately arranged, that means discretely distributed. So here we will try to find out electric field due to n separate charge particles. Electric field of n charge system. So again we have to do the arrangement of charges. So we'll take coordinate system here. Suppose x, y and z coordinate system. We have right now suppose 3 charges. First charge q1 having position vector r1, another charge q2 having position vector r2, and this is our suppose third charge q3 having position vector r3. Now we want to find out electric field at suppose this point P, and its position vector we consider Rp. So now electric field is vector quantity. So what we have to do? We have to find out electric field produced by each and every charge, and then we have to add them, and addition will be in a vector form. So first, if we start with the first charge will produce electric field in this direction. Suppose we write this electric field as E1 electric field. Similar way, second charge will produce electric field in this direction. So this is electric field produced by second charge, E2 charge. Now if we write these two electric fields, then E1 is equal to K, source charge is Q1 here, upon distance from this point to point P. We can write that distance R1P and its square. To show the direction, we are taking unit vector R1P here, which is in this particular direction. So here this can be written as KQ1 upon Rp vector minus R1 vector square. Then, or we can write cube here in terms of vector we'll write. So Rp minus R1 vector. Rp minus R1 vector is this one. Similar way, if we write for E2, then E2 is equal to KQ2 upon R2P caret, or vector magnitude square, R2P. So this is KQ2 upon Rp vector minus R2 vector cube, Rp vector minus R2 vector. Now what will be resultant of these two? So that resultant will get by parallelogram method. Suppose this is E1 plus E2. Now we have one more charge, and that will also produce electric field here, and this electric field will be in this direction. So this is direction of E3 vector, E3 electric field. So finally, if we find out resultant of E1 plus E2 and E3 again by parallelogram method, it will be somewhere over here. So this is our final electric field E, which is due to vector addition of E1, E2 and E3 electric field. So if we write E3 here, E3 is equal to KQ3 upon Rp vector minus R3 vector cube, Rp vector minus R3 vector. And now total electric field or net electric field due to system of charges is E1 plus E2 plus E3 in vector addition form. So we have to add these 3 vectors. So similar way, for n particle system, if we write general formula, then E net due to n particle system is equal to summation I starts from 1 to n k into qi upon r vector minus ri vector cube r vector minus ri vector. So by superposition of all electric field, we can find out resultant electric field produced by n discrete charge particle system.